So here we are with experiment 7, the chemical properties of elements and compounds, chemical reactions. And there is a lot of material to discuss with your individual instructors before the lab. The data sheet for this lab is multiple pages, 3 pages long, and you have to balance the chemical equations and predict the products. This can be very challenging. And what we're really doing in the lab is trying to qualitatively figure out, has a reaction occurred? Did we see bubbles? Did we see a color change? Did we see formation of a solid where there wasn't before? Meaning, could we see through it and then we couldn't see through it at the end? Is it hot or cold to the touch when we touch it with our hands? So all of these types of things can help us to determine, has a reaction occurred? So the first reaction we don't do live because someone complained that it was too bright. It really wouldn't work on the camera that well, although the YouTube video that I found for it is pretty good. And so that reaction involves magnesium burning in air. And that's a very amusing reaction. It certainly was fun for us at the fire department. If you want to do a search for other videos of magnesium fires, they can be quite fascinating because they're unusual in that if you throw water on a magnesium fire, it just explodes. It makes it much worse. And so whenever we rolled up with the fire department on a Volkswagen on fire or a Porsche on fire, whose engine blocks can be made out of magnesium, or if the car had fancy wheels on it, mag wheels, magnesium wheels, we would always give the hose to one of the newer guys and say, "Go ahead," and then they would turn the hose on that, and the car would explode, and it was a lot of laughs for us older folks. In any case, here's the magnesium plus oxygen video. Alright, so let's move on to reaction A. I've got my gloves on now, I've got my goggles for safety, and I'm wearing my coat so I don't end up with holes in my shirt. And it says take a small amount of zinc. So I've got my zinc turnings here. It's just a silvery white shiny powder. Enough to cover the end of a spatula in a small test tube. So, enough to cover the end of a spatula into the test tube. All right, it's in there. A little bit of water because I cleaned out the test tubes before I started because I wanted to make sure I had a nice starting point. And I'm going to add about 10 drops of copper sulfate solution. So, I've got my copper sulfate, that blue stuff that we used a few labs ago in the spectrophotometry lab. And nice neat pipette, 10 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That might not quite be enough to see, so I'm going to add 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Brand new pipette, so I don't mind putting the stuff back into my original bottle. And I'll give it a shake, 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 shake. You can see the silvery zinc in the bottom of the blue solution. And it says set this aside, allow the reaction to take place. And we're going to record our results on the data sheet at the end of the laboratory period. So right now it doesn't look like a whole heck of a lot of anything has occurred. Hold it against something white here for you. You know, it's still a transparent or clear blue liquid and the silvery solid sitting at the bottom. Not a whole heck of a lot going on there. All right, so we'll save that off to the side. I marked it with test tube A, and we will set it aside and move on to number B. So for experiment B, magnesium combined with hydrochloric acid. So here are some strips of magnesium, little strips. Same as what the magnesium fire burning video was. Just have one little magnesium strip there. And I'll put it into a test tube. In the bottom of the test tube. And I'm going to add about 5 to 10 drops of 1 molar hydrochloric acid. 1 molar hydrochloric acid. Here we go. 10 drops. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hear it? Definitely bubbling. We touch it, touching it to the inside of my wrist. It is definitely warm. Close my hydrochloric acid while this is happening. If you go on and take 151, general chemistry, some of you might, you do this experiment and you trap the gaseous bubbling product. And you do an experiment where you figure out the molar mass, you confirm the molar mass of magnesium using gas laws. If we wait long enough, all of this magnesium will react and it won't be there anymore. Now this is a nice example showing how the magnesium is not dissolving, it is reacting. You can predict the products of magnesium plus hydrochloric acid producing a gas, that's the bubbles, and it's producing a salt as the product, and that salt is soluble in water. So eventually it's going to look like all of this magnesium metal has disappeared, but it has not dissolved. It has reacted, forming magnesium cations by giving the electrons away from the magnesium. Magnesium is being oxidized. It's giving the electrons to the hydrogens from the hydrochloric acid, the H pluses from the hydrochloric acid, making those into our gaseous product, which I will let you predict. And an eventual clear and colorless solution, but we're not going to have enough hydrochloric acid for that to happen here. All right? Reaction B. Gets hot. Produces still a clear and colorless liquid and bubbles. We started with a silvery piece of metal. Not all of it reacted, okay? The product is not a silvery piece of metal. You'll have to consider that as being gone. But we certainly haven't produced a product that's a solid. We produced a product that is a gas. That's the bubbles. But other than that, no significant change. We didn't end up with a precipitate, a solid. Again, that's unreacted reactant that's still there. We added more HCl. We get that all to disappear. Reaction D. We're going to add 10 drops of barium chloride. 1% solution, barium chloride. And sodium sulfate, 0.1 molar, if you care about the concentration. We pretty much just want to add equal amounts of each so that we can see what's going to happen. All right? So I'm going to add 20 drops or so to each one. I'm not going to really count because it doesn't have to be exact. Okay? I'm going to add a good bit of barium sulfate, clear colorless solution. a bit of sodium sulfate, barium chloride and sodium sulfate, clear colorless solution. And again, I've gotten a clear colorless solution, right? There's no color to the liquid, but there seems to be another white solid in there. And temperature, no change. No change. Or D. Barium chloride and sodium sulfate, nothing. But it produces a white solid, which might help you with your products. Solids are a result of our solubility rules telling us that we form a precipitate. We form something which is not soluble, which is insoluble. Reaction E, I'm going to take lead nitrate. Find it. Lead nitrate. And this would be lead 2. And add it to potassium chromate. Potassium chromate. Here that is. So I have a clear but yellow solution. Right? Clear just means you can see through it. Or transparent if you'd like. And a transparent colorless solution. Transparent but yellow, transparent and colorless. Equal amounts, 10 drops or so, 20 drops or so of each. There's our potassium chromate. This solution, hopefully none of you have ever had to experience it, is used in breathalyzers. Potassium chromate in the presence of ethanol turns a different color, turns orange. And the more orange it is, the drunker you are, and the more jail time you get. Lead nitrate. Ooh. Look at that. Check the temperature. Nothing. But can't see through it anymore. And let's see if I can do it without spilling it. There's some serious red, yellow chunks in here. Don't spill. I just spilled a little bit. That's what gloves are for. Definitely a yellow solid formed where there wasn't any before. Can I tell the color of the solution? It's hard to say. If there's leftover potassium chromate solution there, it would be a yellow solution, and if there's leftover lead nitrate, then it would be a colorless solution. To me, the solution looks colorless, so I may have had some excess lead in there, but it's hard to say. I think it's a clear colorless solution with a yellow solid. Yeah, definitely. If we can try and not pour it out this time. Yeah, the solution is colorless. The solid is definitely yellow. In reaction G, I'm going to take some sodium bicarbonate, which is just baking soda in water. Oh, I'm going to take a solid. Sodium bicarb. Here we go. It's actually just baking soda. Take the sodium bicarbonate solid and a little hydrochloric acid that we used before in the magnesium experiment. So I have a white solid and a clear colorless liquid. And let's combine those and see what happens. So I'll add the hydrochloric acid first. Get my clean spatula for my baking soda. Whoa, that was exciting. Lots of bubbles. Is it hot? Nope, not at all. Not at all. Same as it was before. If anything, it's cold, but I think the test tube was just cold from the room. But Bubble City, it calmed down already. But that was a whole lot of bubbles. Let's see if we can get it to go again. Why not? See if we have any acid left over. A little bit of bubbles. Not a whole lot. Not as fun as that first time. But you can still see the bubble formation in there. So we are ending up with a gas this time as our indicator of a reaction. Now, all of these are not 100% indicators of reaction. Sometimes you get a color change upon dissolving something. Sometimes you can get a color change, get a color change with a reaction. Sometimes you can get a temperature change by dissolving something. Sometimes you get a temperature change from a reaction. So all of these are qualitative indicators that a reaction may have occurred. Now this reaction is a little bit complicated, especially for Introductory General Chemistry 127, because it produces a product that is unstable and spontaneously decomposes, and so your final products, it's talked about in the introduction, so you might need to go back and read that. Your final products, one of them is a gas. And so this is absolutely a chemical reaction that has occurred. We ended up with bubbles and a clear, colorless liquid. No solid left other than our unreacted starting material. And in fact, if I want to, I can add a little more hydrochloric acid this time, since I clearly have leftover solid. There's not a solid product. If I add a few more drops of hydrochloric acid, let's see what happens. Bubble, 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 as the reaction further consumes the remaining starting material. No solid product. This is a clear, colorless liquid product and gas. In reaction H, it's a strange one. I've got my my colorless white solid and another, it'll be hard to see, white solid. Normally solids don't react in the solid state because the reactants can't really run into each other. They're solids, they don't move, they're just sitting there. The product of this reaction, just like in reaction G, is unstable and decomposes and produces, well, I'll tell you the punchline, one of the products is water in the end. And that, two solids that happen to be in contact with each other react, produce the liquid product, and then the liquid product dissolves more of the reactants, and so on and so on and so on and so on. So let's see what happens with this reaction. I will take some, not my spatula. I should, to be truly protective of my starting material, pour some into the cap and take that in case my spatula is contaminated. But I'm pretty confident, since I washed the spatula before and now I'm wiping it off now, that I'm not contaminating my starting material here. I don't want to take too much. This stuff is pretty toxic, so I don't really want to get any on me. Ammonium thiocyanate is in. Again, clean off my spatula really carefully. I'm going to even use the other end. My barium hydroxide. And I had 2 white solids. Toss it in. Let's see if we can see what happens. Check for the temperature change. Ooh, quite cold. Quite cold. Very cold. And what's going on in there? They were 2 solids. Now I have a liquid, a clear, colorless, let's get it to move down, there we go, a clear, colorless liquid. The more I react it. Woo, and it's quite cold now. And definitely liquidy. And if I could see through it, without the presence of any unreacted starting material, you'd see that it is definitely clear and colorless. Really, really cold. Very endothermic. Pulling in energy from the test tube, from my arm, to supply energy to this reaction as it goes on. Two white solids produce a clear, colorless liquid. I know it looks like there's still a lot of white solid. That's not product, that's unreacted starting material. Reaction I. Barium hydroxide. And our old pal, the hydrochloric acid. Hydrochloric acid is in. Barium hydroxide, a little toxic, is in. No bubbles. Ooh, a bit warm to the touch. White solid, clear colorless liquid produces clear colorless liquid. No solid at all. No unreacted starting material this time. Definitely no solid product either. Definitely clear colorless liquid. A little warm. So if you missed any of those, you can go back in the video and look for the section title. And let's go back to test tube A and see what we got. Since we're at the end of our experiment time. We had a blue clear liquid that is now not blue anymore. We had a silvery solid that is now black. Or at least much, 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 much darker. Hold it up to a paper towel. Well, that's interesting. Clear, colorless liquid and a dark, blackish solid. Certainly not a blue transparent solution that we started with, and the silvery solid that we started with. So this is, again, back to reaction A that we were going to look at the end of the laboratory experiment. This is another experiment that if you take general chemistry, you explore this in some great detail to figure out exactly what's going on. But you'll still need to predict the products of zinc plus copper sulfate. What do we have now? It's not zinc and copper sulfate anymore, I can tell you that. Because if there was copper sulfate still here, it'd still be a blue transparent solution, and it's a colorless transparent solution. And if we still had zinc, it would be shiny silvery. And it's not. It's blackish. Certainly a whole lot darker now. So we've got something new, because a chemical reaction occurred. Per the title of this reaction, per the title, of this lab, chemical reactions.